Today will be section 4.3, properties of logs. We're going to separate this section into 2 days. Today we're going to work on what we call the expansion of logarithm expressions. And to do that, we're going to use 3 properties of logs: the product rule, the quotient rule, and the power rule. These are the same type of rules but for exponents, and I just want you to pay attention to the operations that are happening in these. These are all rules that we've used in this class. If we have 2 exponential terms that are being multiplied and the bases are the same, we're allowed to add our exponents together. So in the product rule, there is a component of addition. When we are dividing, or we have a quotient of 2 exponential terms with the same base, we have a component of subtraction. We're allowed to subtract those exponents. Power rule, 1 base, 2 exponents, we're allowed to multiply. So I want you to see the connection between multiplication and addition, division and subtraction, and multiplication, and what we're allowed to do there. These are the 3 properties of logs. These are the only 3 properties of logs. These rules are the only things that we can follow and use to expand a logarithm expression. So the product rule for logarithm says if we have a log expression, we have 1 log, 1 base, but there is a product within that logarithm expression, then we can separate that product into their own logs and we will connect those new logs by addition. Here there's only 2 parts of the product. If there are 3 parts of the product, we will have 3 new logs. If there's 4 parts to the product, we'll have 4 new logs. The quotient rule says that if, again, I have a logarithm with a base and I have a division, then I can separate the numerator into a log, the denominator into a log, and I will subtract those logs. The power rule says that in my log, anytime I have an exponent, that exponent is going to be moved out in front of the original log to become a coefficient or a multiplier. We're going to use these 3 logs to expand logarithm expressions. Now, you may be able to only use one at a time, but there will eventually be expressions where you will have to use all 3 rules together. My advice is to always start with, is there a product or a quotient first? Separate the product or quotient and then deal with your individual new logs and ask yourself, in my new logs, are there any other products, quotients, or powers? So let's try some. Expand each log by using the properties of logarithms. Expand means to make bigger. Once you expand, if possible, evaluate your new logs without a calculator. Remember, that is saying, is there a power to some base that gives me the number in my expression? So remember, we had log base b of x equals y. So we need to ask ourselves, does b to any power of y equal x? So we're trying to determine this. Is there a value of that log that would represent my exponent in my exponential form? Okay, so here we have 7 times 11. That is a product. So we're going to separate that 2-part product into log base 6 of 7. By product rule, we're going to add a log base 6 of 11. Now we have 2 new logs, so we need to ask ourselves, does 6 to any power equal 7? Well, that answer is no. That means that logarithm doesn't have a value that we can calculate without a calculator. We would need a calculator to do that. So we can't reduce that one. Over here, does the base 6 to any power equal 11? Again, that answer is no, so we can't evaluate that log without a calculator. So this is our expanded version. 7 is a number. There's no power we can move in front. There's no other product there. There's no quotient, and same with this log. Example 2. We have log of 100x. Remember, when you see the word log but no base is given, we assume it's a log base 10, meaning that that is a common log. So 100x is a product, so we're going to have the common log of 100 plus the common log of x. Remember, now both of these have a base 10, so if possible, evaluate without a calculator. So this common log is asking, does 10 to any power equal 100? Well, that answer is yes. 10 squared equals 100, so this log has a value of 2. So my final answer will be 2 plus the common log of x. Example 3, we have log base 8 of 23 over x. This is a quotient. So I will separate a log base 8 of my numerator minus, because of the quotient rule, a log base 8 of my denominator. This is an x, so we are not going to be able to simplify that without a calculator because we don't know what x is. But if 8 to some power gives us 23, we could simplify that. But there is no power of 8 that gives us 23, so this is our simplified answer. Okay, this page, or this example, we have a natural log. Remember, natural log, ln, is the same thing as a log with a base e. So again, this is a quotient. So we have the natural log of e to the 5th minus a natural log of our denominator 11. Now this is the first one where here we have a power. So the power will come out in front of that natural log of e minus the natural log of 11. Okay, now, if you remember from the first section, the natural log of e by property equals 1. So we move this up here. So this means 5 times 1 minus the natural log of 11. So my final answer is 5 minus the natural log of 11. Okay. You also have the property of the natural log of e to any power of x equals that power of x. So we could have used this property here. Natural log of e to the 5th has to equal 5. But we can also use the property or the power rule there as well. Okay, moving on. You'll notice that in the properties, there is no power or there's no rule for roots. So we have to figure out what to do with a root. Okay, so here's another rule. The square root of a, okay, is the same thing as a to the 1/2 power. So if we look at this as a rule, a to any power of m to the nth root. To change a root to a power term, the base a is going to be raised to the m over n power. So the square root of a, okay, remember any variable without an exponent means the exponent is 1. The square root means what number times itself, so we're looking with a second root. Okay, so another quick example, if I have the 7th root of a to the 4th, that is equivalent to a to the 4/7 power. All roots can be equivalent to an exponential term. You will always have to change roots to an exponential term first in order to successfully expand it using the power rule. So before I worry about any rules, I'm going to worry about this root. So I'm going to change this to log base b of x to the 4th times y to the 1/3 power. Y has an exponent of 1. We're dealing with the cube root. Now I can successfully expand this, first using the product rule, so log base b of x to the 4th plus log base b of y to the 1/3. And then each of my new logs has a power, so I'm going to use the power rule to pull that exponent down to a coefficient and become a multiplier of the log. And I can't simplify any of these logs because I have variables in them. So because I have used the product rule successfully and then the power rule successfully, I am done. Okay. Next one, again, I'm going to change the square root of x to x to the 1/2 power. Then I can start expanding. So this is a quotient. So my numerator and denominator are going to separate into their own logs. So I have log base 5 of x to the 1/2 minus log base 5 of 25y cubed. Now I need to use the properties within the newly created logs. So this first log here, I can use the power rule. So I'm going to pull 1/2 down of log base 5 of x. Now my second log has a product in it. 25y cubed means 25 times y cubed. So since I am subtracting a product, I have to put a parenthesis there. Then I can expand that log. So I'm expanding it to log base 5 of 25 plus log base 5 of y cubed. I have to put the parentheses around that product to show that I am dividing by a product. If I don't put parentheses there, then I'm showing I'm dividing by this term, but not this one. Then I can keep going and simplify. I can't do anything here because I have just an x there. I've already expanded using the product and the power rule. So 1/2 log base 5 of x minus subtraction, or parenthesis, log base 5 of 25 equals 2 because 5 squared equals 25, plus, pull the 3 down using the power rule, log base 5 of y. Now, in terms of properties, I am done. But now, to finalize this answer, I need to distribute this subtraction into the product. So my final answer is going to be 1/2 log base 5 of x minus 2 minus 3 log base 5 of y. Okay. Now this is the only type of problem when you have a product on the bottom where you're going to have to add in those parentheses. If you don't, you won't show this true division by a product. Okay, again, here we have log base, or common log, sorry, there's no base there, of the 5th root of x over y. I'm actually going to change this to x squared over y because I want to make sure you remember using another rule that we already talked about. So this entire fraction of x squared over y is under the 5th root. That means this entire fraction has to be raised to the 1/5 power. Okay, then at the beginning of this lesson, we talked about if I have an exponential term raised to another exponent, that I have to multiply those. So before I can expand, I have to know the true value of the numerator and the denominator. So this is going to change to common log of x squared to the 1/5, which becomes x to the 2/5 power if I multiply those. Remember, 2 is 2 over 1, over y to the 1/5. Okay, that uses the quotient raised to an exponent. The exponent has to go to both the top and the bottom. Okay, so I used both of these rules to simplify this. Okay, now I can expand. This is a common log. Remember, that means there is a base 10 there. I'm not going to write it, but I need to know it. So this is going to be the common log of my numerator, x to the 2/5, minus, because it's a quotient, common log of my denominator, y to the 1/5. And then I can pull that exponent down because of the power rule. 2/5 times the common log of x minus 1/5 times the common log of y. Now if we were in class, this is when I would separate you into groups and you would work on these 5 problems together. Since we can't do that, I'm going to explain them for you. Okay. Common log, log base 6 of 3 to the 9th, that's just a power rule problem. Pull that 9 down in front of log base 6 of 3. The only way we could go farther is if 9 could multiply by the value of log base 6 of 3, but 6 to no power equals 3, so I can't go any further. This would be my final answer. This is a natural log. Remember, we need to change the cube root of x to x to the 1/3. And then I pull that 1/3 in front using the power rule of the natural log of x. This is one where people tend to overthink it. Okay, remember, if this was a polynomial on its own, to square it, it would mean x plus 4 times x plus 4. But they're not asking us to find the product. They're asking us, how do I expand this? Okay, well, this is a sum. This expression is made up of a sum and an exponent, or a power. We don't have a sum rule. There's nothing that tells us how to expand a sum, but there is a property that tells us what to do with powers. So all we can do here is pull that power down in front and leave it as 2 times the common log of the sum, x plus 4. Can't do anything with that sum, so I have to leave it as is. This fourth one, here we have a product. So we have the common log of 9 plus the log base 9 of x. Let me read that again. Log base 9 of 9 plus, because of the product, log base 9 of x. I can simplify this log because the base 9 to the first power does equal our answer of 9, so this will become 1 plus log base 9 of x. And this last one tends to get people all worked up because it's long. Okay, I'm going to rewrite it on another page so that I have a little bit more room. So I have the natural log of x, let me get to it here, of x to the fourth times the square root of the sum x squared plus 3. That product is divided by the sum x plus 3 raised to the 5th power. Let me check to make sure that's the same here. Yep. Okay, so it is big, but it really is not scary because it really is only made up of 3 components. We have the natural log of x to the fourth, and then we have a root, so I need to change that root, x squared plus 3, to the 1/2 power. All of that is divided by x plus 3 to the 5th. Now I can start expanding. Okay, in the numerator, I have x to the fourth times x squared plus 3 to the 1/2. I'm going to subtract, because of the quotient, a natural log of my denominator, x plus 3 to the 5th. Now, a common mistake here is that people misuse this rule, and they try to apply this exponent to this and that. That doesn't work with it when this is a sum. Remember, this is the rule. Okay, we would have to multiply that by itself. Okay, 1/2 means this sum is multiplying by itself 1/2 times. So we're not going to expand this at all. But in this log, we are going to expand the product. So natural log of x to the fourth is going to add to another natural log of x squared plus 3 to the 1/2. Now you may be asking, do I need parentheses? The answer here is no, because it's on the top, which means there's a plus sign in front of it. Parentheses aren't going to change the value of these 2 logs. Okay, minus the natural log of x plus 3 to the 5th. Now I have 3 new logs, 2 that represent the product in the top, 1 that represents my denominator. Each of these 3 logs has a power, so using the power rule, I can pull that down in front of each natural log. Then I need to check again. I have 4 times the natural log of x. X has no power, more powers, it's not a product nor a quotient, plus 1/2 natural log of x squared plus 3. Now I do have a power here, but that power is attached to a sum. Because I can't separate the sum, that power stays there. Minus 5 natural log of x plus 3. Again, another sum. There's no other products, quotients, or powers here. So this is my final answer. If you have any questions, please let me know.